It's a wonderful experience to discover a fossil and realize that you are looking at something that existed possibly millions and millions and millions of years ago. But how many millions of years ago? We need to be more specific, and scientists need to find ways that they can record or determine the date of that fossil. When was that fossil formed? So we move now to look at dating fossils. How do scientists work out how old a fossil is? Well, there are a number of methods that can be used to determine the age of a fossil. And scientists will try and use as many methods as possible, because as the more evidence that they get that points to a particular age of a fossil, the more compelling, the more reliable that evidence is. And so one method is relative dating. Relative dating is also called an indirect method. Index fossils, which is also an indirect method, and something called radiometric dating, which is a direct method. It works directly on the fossil itself. So what we're going to do is look at each of these ways to date the fossil in turn and see how it's done. So we're going to start off with relative dating. This form of dating allows scientists to say that one fossil is older than another, but it doesn't tell you how old the particular fossil is. Now, you can look, for example, at your grandmother and your mother. And according to the number of wrinkles that your grandmother has, you can determine that she is older than your mother. But that doesn't tell you what the age of your grandmother really is. You just know that Granny is older than Mother. So that is what we're looking at when we look at relative dating of fossils. A fossil that is found down here is probably going to be older than a fossil that is found up there. And so by looking at the relative position of the fossils in sediment and comparing it to other instances where you found, say, fossil A and fossil B, you're able to say, well, fossil A, we think, is older than fossil B, because every time we find fossil A, it is beneath fossil B in the rock strata. That is called relative dating. So we know that sedimentary rocks are laid down in layers. Oldest layers, and therefore fossils found in those oldest layers, would be determined to be older, and the youngest fossils will be found in the youngest layers of rock towards the surface. Index fossils, well, we find that there are certain kinds of fossils that exist around the world that are very common, and they're always found at a particular time, or the time at which those animals or plants were fossilized is very characteristic. We know, for example, that fossil A was always produced 100 million years ago. Always. We know about fossil A. When we are therefore looking at possibly a cliffside here, and we find this particular fossil, fossil 8, always together with fossil A, we know if 8 is found with A, and we know that A is 100 million years old, 8 must also be 100 million years old. And so it's a way of correlating our information. If we know index fossil B is always found 500 million years ago, we've dated that for certain, and we find this particular fossil together with lots of B in that stratum or that layer, then we know that fossil number 3 is also probably 500 million years old. Radiometric dating is a lot more accurate and a lot more specific. Instead of saying, oh, well, the fossil is found at this level, which means it's older than that, or fossil A is found together with fossil B, so they must be the same age. Radiometric dating gives us a precise record of the age of the stone. We know that certain atoms release particles over time. For example, a uranium atom over a long period of time gets converted into a lead atom every 700 million years. So if we were to find a rock that had a certain percentage of uranium compared to the percentage of lead in it, we could determine precisely how old that particular piece of rock is. More after the break.